Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rohini College of Engineering and Technology. Now I am going to handle the subject on Communication Engineering. So here I am going to discuss about the topic on Quanternary phase shift keying, that is Quadrature phase shift keying, QPSK. So on completion, the QPSK, the students will be able to define Quadrature phase shift keying, draw the block diagram of QPSK modulator. So quaternary phase shift keying, that is QPSK. The basic principle is behind the communication systems. We know that are two main resources, that is the transmission power and the channel bandwidth. The channel bandwidth will be depends upon the bit rate or signaling rate, that is FP. In digital bandpass transmission, the carrier is used for transmission. This carrier is transmission over the channel. So if two or more bits are combined in same symbols, then the signaling rate is reduced. Therefore, the frequency of the carrier is required is also reduced. This will be reduces the transmission channel bandwidth. In quadrature phase shift keying, the two successive bits in a data sequence are grouped together. So this will be mainly reduces the bit rate of the signaling rate, and hence this will be reduces the bandwidth of the channel. So in QPSK, the two successive bits are combined. This combination of two bits form the four distinct symbols. So when the symbol is changed to next symbols, so the phase of the carrier, this will be changed by 45 degree. So the combination of the two bits will be called as the digits, that is D bits, that is 0001 1011. So for each 2 bits debit clocked into a modulator, a signal output changes over and the rate of the change at the output, this will be equal to 1/2 the input bit rate. So this is the QPSK modulator diagram. So what is the function will be carried out in the QPSK transmitter means the two bits are clocked into a bit splitter. After both bits have been serially inputted, they are simultaneously parallel outputted. So the one bit is directed to the I channel and the other bit is directed to the Q channel. So the I bit, this will be modulate a carrier that will be in phase with the reference oscillator. So the Q bit, this will be modulate a carrier that is 90 degree out of phase or in quadrature with reference carrier. So once the D bit has been split into the I and the Q channels, so the operation is same as the BBSK modulator. A QPSK modulator is two BBSK modulator are combined in parallel. For logic 1, that is plus 1 volt, and the logic 0 is equal to minus 1 volt. Two phases are possible at the output of the I balanced modulator, and the two phases are possible at the output of the Q balanced modulator. For I balanced modulator, this will be taking plus sine omega ct and minus sine omega ct. For Q balanced modulator, plus cos omega ct and minus cos omega ct. So when the linear summand, this will be combined the two quadrature signals. So here we are having the four resultants phases. This is the truth table for the QPSK. That is, here we are having the binary input Q and I, that is 0001 10 and 11. So the phasor expression, these are minus cos omega ct minus sin omega ct and minus cos omega ct plus sin omega ct plus cos omega ct plus minus sin omega ct plus cos omega ct plus sin omega ct. And the QPSK output phase, here we are heading minus 135 degree and minus 45 degree and plus 135 degree and plus 45 degree. So these are the different output we are getting. So this is the QPSK receiver block diagram. So in the thing, the power splitter, this will be direct the input QPSK signal to the I at Q product detectors and the carrier recovery circuit. So the carrier recovery circuit, this will be reproduces the original transmit carrier oscillator signal. So the recovered carrier must be frequency and phase coherent with the transmit reference carrier. So the QPSK signal is demodulated in the I and Q product directors. This will be generate the original I and Q data bits. So the output of the product detectors are feed to the bit containing circuit. So they are converted from the parallel I and Q data channels to a single binary output data stream. The incoming QPSK signal may be any one of the four possible output phases. Let the incoming QPSK signal, that is minus sine omega ct plus cos omega ct. The quiz question is based on the quadrature phase shift keying is what is the maximum data rate that is can be transmitted using the QPSK modulation with a roll-off factor of 0.2 for a 36 megahertz transponder is dash. Thank you.